Hello, my name is Dolina. This is another question from the communicating. So, log x plus log y is equal to log x plus y. Is this true? Well, no. Let's see why not. So, let's assign x is equal to be 1 and let y equal 2, for example. Now, let's plug these values in to here. So, plugging them in, log of 1 log of 1 plus of log of 2 equals log x plus y. Oh, sorry, uh, 1 plus 2. So over here, this seems all pretty simple and everything looks pretty good. But log 1 is actually 0 right here. I've designed this before starting this. Log 1 is actually 0. Well, if log 1 is 0, what is log 2? Well, log 2 with a base of 10, when there's no base here, when there's no base, that means our log is automatically a 10. So our log of 2 base 10 is actually 0.301. And then our log inside here, log is 3. Log is 3. Now, if this side is 0.301, left side has to equal right side. Well, 0.301, but what is log 3? Well, log 3 is actually 0.477. Why is this the case here? Well, this is due to a thing called the quotient. Oh, sorry, not the quotient. The product rule. The product rule states the product rule up here. It states log b, which is base, m times n is equal to log m plus log n. Let's try to prove this. So, proving this is proving this is actually quite simple. All you have to do is assign a number. So I'm just gonna rewrite this in a different color. So let's do it here. So log x plus log of y equal log xy. Let's try to prove this and then use the same example we did here just to do it back. So let's assign a number for log of x. Let's say log of x is going to be m and log of y is going to be our n. Well, if these two are set, that's going to be log x is equal to m. Log n is equal log y, my fault. Log y equals to n. Well, you could also rewrite this by using the forms up here as sorry as equals 10 and not equals but arrow just to show the transitions. It's going to be 10m equals x, so 10m as the exponent equals to x, and then 10n equal to y. So now from here, if this part, let me choose a different color now. If this part is this, x and y is this, that means our x and y here could be replaced with our x and y here. So let's try that. We're saying xy is equal to 10m here times, or that's adding, times 10n. Since we have the same base, or the same 10, you don't actually multiply, you actually add the exponents. So that's going to be 10m, that's not m plus n, xy. So 10m plus n, 10m plus n, this could be now written as a log. So writing this as a log, that's going to be log log xy is equal to log 10 bracket m plus n. So now it's like this. Well, where do you go from here? This doesn't look anything close to our log value here. Well, this is where it gets interesting. Now, using our what was it, product rule, I believe? Sorry, our power rule, we could bring this to the front here. So that's gonna be, I'll use a different color to show that part. So m plus n is gonna be up here, and then log, gonna try to go back to that same color, but log 10 log xy bracket bracket. So from here, our base is actually log 10 too, since it doesn't have to be written down since that's the base. So log 10 and log 10, they kind of cancel out because log 10 and log 10 pretty much just becomes 1. So m plus n is going to be the remainder. M plus n log x, y. Now, from before, we know our assigned numbers. Well, we assign numbers to our m and n. So what's our m? Our m is log x. So writing this down, log x, y is equal to, we replace it with the numbers that we assigned. So I'm going to write that in pink. That's going to be log, here, that's x, log x plus log y. Here, we could see that this is equal to this. So our left side is equal to our right side. So that's why this question this question does not equal left side equal right side. Instead, this is just the product rule, which we applied here to figure out if our value actually is true or not. So let's move on to the next question, which uses quotient rule, and let's solve that one there. Alright, so this is the next question. This question is using the quotient rule, which is the rule here. So let's try to prove why this doesn't equal that. So getting started. So I stated here that x equals to 1, y equals 2. So log 1 divided by 2 will actually give you negative 0.30. But log 1 log 2, even from up here we could see that log 1 is 0. So if log 1 is 0 and log 2 gives you something around 0.3, 0 divided by anything will actually give you a 0. So left side does not equal our right side. Let's try to prove why. So here in this example, let's just use the quotient rule. So I'm just gonna use the yellow color again, and let's just get started on this side. So I'm just gonna mark this off, so it's separated, and then use a bit more different color. Let's just use green. So the quotient rule states that log, in this case our base is, let's just say 10, so we're not gonna write it down. M over n is equal to log b, or our log 10, m minus log n. So let's try to prove why our left side equals to right side, and this is how it works. So again, like we did before, let's assign numbers to all of this. So log m is equal to x. Log log n is equal to our y. Now, writing these down, so I'm just gonna write an arrow here. That's gonna be 10x, because that's our base here. 10x equals m, and then next one is gonna be 10y equal n. So now we have this. So let's rewrite the equation again. So not this, with this like we did before. So I'm just gonna do that there. So log m over n, obviously our base is 10, is equal to log, what is it? M over, yeah, sorry. So that's gonna be log 10 over x, or yeah. So that's gonna be first 10 over x because that's our n, and that 10 over y, and we know our base is 10. So I'll just write that down just so we remember. So moving on to the next step, well, these both have the same, they both have 10, but they have a different thing, different numerators. No, sorry, different exponents. Therefore, we could rewrite this as log 10. When it's getting divided, you subtract. So that's going to be actually x minus y, base 10. Now, using, I believe, what is called the power rule, we could bring this to this side. That's going to be x minus y. And then I'm just going to switch up the color again. Log 10 base 10. There we go. Again, 10 and 10 will give you 1. So that's not going to affect our value here. Therefore, we're left with x minus y. Now, what we're going to do is we're going to rewrite the equation one more time. So now we're going to write log, I'll use a different color again. So log m over n, let's just say base 10 here, is equal to another color, our x minus y. X minus y. Now, we assigned values for our x and y. Well, what's our x and y? So from up here, we can see our x and y is these values. So our x is actually log m, and our y is log n. So minus log n. So our log m over n equals log m minus log n. So that's how you could prove the quotient function and the other one, which I'm just forgetting the name of, which is sorry, the product rule. So that's how we could just check if something equals, or to prove. So thank you very much. Have a good day, Mr. Didi. Uh, thank you. Bye bye.